Your board's still wet, or is it not wet? Looks wet.
It's just greasy.
No.
So Pascal's triangle concept is you start at 1 at the top, 1 to either side of your next row. The addition of the previous 2, I think you just automatically start with 1. So then you go back down to 1, 2 plus 1 is 3, 2 plus 1 is 3, 1 on the outside. 1 on the outside, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 on the outside. And this continues all the way. It actually has a trend where it comes 1, boom, 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 and you just have to worry about the outside terms, so you have 10, 10, yep, and then 15, 20, and 15. I'll just stop at 6. So, if you remember back in the day, whenever you'd see a problem that said x plus h quantity squared, whatever that quantity is, can be to the nth, whatever you, well, usually you only learn up through the binomials. Binomials would give you x squared plus 2xh plus h squared. And you know that because FOIL. Of course, I'm treating you guys like you went through this, so I'm just kind of going on a assumption here. X times x squared, x times h plus x times h plus h squared. You guys remember the FOIL? First, outside, inside, last. Yep. You come up with h squared, you combine these two, boom, 2. So that's how we came up with that answer for an x plus h quantity squared. But when you get to cube roots, now you have to take x squared plus h times x squared plus, or x plus h times x plus h. So you do the FOIL method, and then you do the FOIL method a second time, as you get a fourth nth root. You get more and more. So we will start at 1, 2, 3, 4, just like their number, 5, and 6. And for every x plus h quantities raised to the nth term, that nth term correlates with this line. So as an example, if you take x plus h to the 6th, we'll go our bottom line because it'll be fun, which is the equivalent of taking x plus h times x plus h times x plus h, x plus h times x plus h, 1, 2, 3, 4, 5, 6, multiplying all those together, just like we did up here, but now you're doing it 5 times. Using Pascal's triangle, you can go a lot quicker. X to your nth term. Your first coefficient is going to be 1, x, h, and you're going to start at 6, 5, I'll come back the other direction. Our next term, 6, coefficient in front of the exponents, or the variables, you're going to go 4. Next term is 15, 3, 20, x2 plus 50, oh, I forgot my h there, need a little more space, 20, back down to 15, we're just at 1 now, 0, any variable to the 0 integer is always 1, so 1 times, where did I get my 12 from? That's a 15. Our next term would be 6, 0 would be 1, or 1 would be 1, I'm sorry. So we're at 1. Now 0 would give us 6, x, h, except that x is a 1. Or it turns into the number 1, so then you're at h. I'm kind of stumbling here. Okay, there we go. X to the 6, and you go backwards. 5, 4, 3, 2, that would be a 1, 0, x disappears. So using Pascal's triangle, even if I go on a smaller scale, we'll go 3, so x plus h, the quantity cubed, be the equivalent of 3 of these. So you can just come right across. You start off with an x cubed. You're going to have a, also I won't even put the variables in front, you'll have an h, or xh plus an xh plus an h cubed. And then you work backwards. 3, 2, 1, 0. 3, 2, 1, 0. Using Pascal's triangle, what would take someone, for me to foil that, it would probably take me 45 minutes. And I just did it in what, 13? 5 minutes? And I did x to the quantity cubed, to the 6th root, to the nth root, any of those.